welcome back to the channel, and today we are knee-deep in mud because we are showing you behind the scenes of the Jurassic Coast X-Prix. We are going racing with Extreme E, and this is the paddock, and I'm going to show you behind the scenes. Come with me. They say that Extreme E is the most intense form of off-road motorsport, electric motorsport as well, and I can't disagree when you look at this. Now, it might not be the temperature extremes of Saudi Arabia, the intensity of Greenland, where you were really in the middle of nowhere when we went racing there, but this is certainly going to be challenging for the Odyssey 21s, those vehicles, those off-road SUVs, all electric power that they use in Extreme E. Now in here, we're going to come back and have a look at a car a little bit later. This is Spark Racing Technology. They developed the vehicle alongside the team behind Extreme E to a brief. Everything was custom built for Extreme E. So the chassis, the space frame, the powertrain, Williams Advanced Engineering, we're going to have a chat to them a little bit later. The battery packs, all custom designed for Extreme E. Even the tyres as well. The brief went out to Continental for the kind of tyres they needed. You can see them down here. So this tread pattern, they haven't gone down quick fit and got these off the shelf. This brief was into Continental for the series long before we ever went racing. And these vehicles have to cope with extremes of temperature, extremes of pressure going all around the world, whether it's plus 40 degrees Celsius or minus 20 degrees. They're going to be on, we're going to be on sand and gravel and stones. And as you can see here, I mean, look, we've only just started shaking the cars down and it is already a mud pit here. It's actually somewhere called Bovington Tank Museum around here, but this is actually Army territory. You see some Army folk around here actually. This area is where they test tanks. So if you want to go to one of the most extreme areas, go to where they're testing tanks. This is the RXR garage here. Of course, Nico Rosberg is feeling festive, and why not? Because we're just before Christmas as we are racing here in the Dorset countryside. Cheers, the ship that's been transporting these race vehicles all around the world in season one, and will continue to do so, by the way. Here we have the Chip Ganassi garage, and you can see when they come back, and this has been cleaned. Lewis Hamilton's X44 team, by the looks of it, they're around this crazy circuit. And it's throwing up so much behind it. Have a look at the JBXE car coming out. Clean at the moment. But it's not going to stay that way for around the world with the various locations they've been going to. There's the JBXE car. What will be a kind of start line Argentina. Various restrictions meant we couldn't be racing there this time. However, it doesn't mean that we can't come close to big attention here in Dorset, working with the National Trust. And so, one of these insane Odyssey 21s. Come with me.
Sardinia. Check out that video on the NLX channel. You can follow.
I promised you a look behind the scenes at Extreme E, and as one car heads into, this is Williams Advanced Engineering, it'll be getting its battery checked or some sort of health check. Come with me because we are going to give you an access all areas look at the Odyssey 21. This is, what a beast. This is what they built exclusively for Extreme E. Now I'm going to get the stats on this to get it right. It's 2.3 meters wide, 50 millimeters, and it's got a 3 meter long road car. The first thing I'll say about this is whenever you see a racing car, and I've been fortunate enough over the years to see plenty up close, they're always smaller. Let me tell you, it's way bigger than it looks on TV. It's just a beast with the doors open as well, and it's so imposing with these massive Continental this racing car. So screens showing the feeds from the cameras, and of course all of the telematics from the EV. Now if you drive an electric vehicle like me, you might be kind of interested in what's your efficiency, how many kilowatt hours have you used, that kind of thing. Now these guys get a whole tucked in here. And one of the interesting things about Extreme E, of course, it's a have an electric seat moving forwards a bit and back a bit. It's not the way it works in a racing car. So with all of the experience in Formula E, we're commissioned by Extreme E to build this vehicle for the first season, and it will roll on as well, and achievement it is. But my favorite bit is just in here, just a CCS Combo 2 plug. Now, it'll be from a parts catalogue or something, but of course this is where I get the charger plugged in to that 50 kilowatt hour battery pack. You can see, as if you drive an EV at home, you've got the orange cables in here. That's all the HV stuff. That's your high voltage things coming out of the inverter in here. We have some electronics. You can see the incredible suspension, and the wheel travel on these vehicles has to be huge to cope with everything that they go through. As we look down at the transmission as well, four-wheel drive, of course, and the same motors at the front and the back of the vehicle. Now, I think it's 470 kilowatts of power for these vehicles, but if that's wrong, we'll put it on screen or something to correct me. So an incredible piece of access that they've let us have here. As they start drilling in the back, we'll make our way out. But you can see here, as I mentioned, those screens, this is what they are showing. So we've got, I was going to call them wing mirrors, but you've got the side cameras here to look back. It's very close racing, of course, in Extreme E. And if I can get Matthew to watch his head as he comes around and have a look up there, you've got a forward-facing camera on the roof, some comms stuff up there as well. And even though the guys from Spark are over here looking very relaxed at me talking about their vehicle, the green light is on here, so I presume that means everything is okay. What a spectacular EV. I've got to be honest, I wouldn't mind one of these in my driveway. You know, a trip to the shops at the weekend, get a pint of milk in this, that'd be all right. So to finish off our tour backstage at Extreme E Live, we're here with Fred from Williams Advanced Engineering. And Fred, you're going to show us around some of the battery technology that you've got here as well. And I couldn't help but see you've actually got complete battery packs. Are these like complete spares for the teams?
Yes, so we have a ninth race car with nine packs. And here I have two more spares, dent or crash, or if something for some reason might go wrong, so I can quickly swap the battery and get the car rolling. And then we have here all the equipment to fix it, to repair it, or to maintain the packs. And as soon as I can, I bring back the battery back to the car, so every teams have their own battery.
So this is what Williams Advanced Engineering supply to the teams as a finished battery pack. They've got to do nothing with it apart from, I presume, they bolt it up underneath the car.
Yes, exactly. So this is this pack comes from you install it from the bottom of the car. You have 17 screw around that close a hole in the chassis basically. Yeah. So here all around, and then once the battery is in the car, there is a piece of frame that come and close down the chassis for reinforcement, and then you have a floor to protect the whole thing.
Now, I think most people with electric cars at home are used to seeing those pictures of what they call a skateboard design of flats. Was it better in a way to do that? What were the challenges?
Well, I think in that application, we wanted to have the center of mass concentrate behind the driver. So where normally you will have the engine and tank on a IC engine, and having it compact in one place reduce the inertia, the whole inertia of the car. And because of the off-road use of this car, having a skid under the car would be kind of problematic, maybe in some extent, some jumps. And so here we have the battery really on the back of the driver. So the driver is sitting just here in the front. This is just sitting behind. And then this is about 100 millimeter above the skid to have some space for protection as well in case of shocks.
Now, when we had a look at the car over there, it is a CCS Combo 2 plug, like somebody would just plug their car in at home. So it really is like they can draw that line from racing and Extreme E to what is in their driveway and their garage. But of course, you know, similar technology, but actually what's inside, for anyone that drives maybe a Tesla Model 3 or a Model Y, that 21700 cylindrical cell, again, that's what. Can we have a look at those? These are what you've got inside here, right?
So we have in this battery about a bit more than 3,000 cells. So the cells are just standard, not really standard, but let's say.
I'd love to see these.
Yeah. So this is what the part we are carrying to maintain the battery, to make sure they have to the maximum specification. So this is what we call a module. So you'll have on a module, you have here every single cells. All the cells are well together in a sub-module, let's say, and then all the sub-modules are put together as a module within a space which is easy to handle. So on some standard cars, I mean public cars, this module is bigger because it's handled by crane during the assembly process. Here, because you have to carry it around, we keep it to a really reasonable size, so we can easily, you know, take it. And
these are the cells that, you know, not quite laptop batteries, but people will
just a bit bigger, yeah.
You know, people will recognize.
So you see, we can handle it easily. It's about, it's a bit like 8 kilo, something like this. So you can easily carry it, take it away. And because our environment is quite rough, here it's muddy. In Saudi Arabia, it was windy, sandy, and so on. So it needs to have let's say an acceptable size to be able to be used, basically.
Now, the modules that people would use in their home cars, for instance, a lot of thermal management going into those because people want increasingly fast charging speeds, whether it's you know, the new Hyundais and Kias at watts possibly. So, but I can see there's no heating or cooling actually at module level for you. So how do you thermally manage those batteries in the race cars?
Because the race is quite short, the whole idea is to precondition the battery to a target temperature and then go for the race. And during the race, the battery simply get warmer and warmer and warmer to a point where when we finish the race, we are within acceptable range.
The battery down.
So on this model, on this specific series, we choose to use air cooling.
And so you're blowing. Is it these holes? So literally just a big pipe, and you're blowing some cool air all the way through.
The ducting is something like this. It's mounted on the plate you show, and at the end of it here, we plug a air conditioner, like a standard air conditioner you're going to be used for, I don't know, weddings or, you know, distance during weddings. So it's just blowing air at about 8 degrees. Help with the fan to get more mass flow. And all together, you cool down the battery while we charge it between 2 sessions.
Now we've seen the chargers around with NLX on, and the chargers in the garages as well. How fast do these cars charge?
So the NLX charger are meant to be 60 kilowatt hour. When only few cars charging at the same time, the system here, the grid, because it's a let's say a field grid with the hydrogen. So if it's only few cars charging at the same time, they can push to 40 kilowatt. But when all the cars need to be charged, they have to drop to 20 kilowatt. Not because the charger or the battery cannot take it, it's just because in the field, it will be too much stress for the system to go 40 kilowatts for all the car, for all the charge.
And is that how the teams, do they constantly top up charge? So they go out, they'll do a shakedown run or a qualifying run, they come back to their garage. Are they plugging in straight away?
Yes, simply because when you are battery fully charged, you have the maximum voltage, right? And if you have more voltage, you have less current for the same power. As we limit the power, more voltage you will have, less current you will get. And less current you will get, less temperature you will get. So you always want to be at the maximum voltage to generate the minimum current.
Now my car at home runs at about 450 volts. Maybe someone driving a Tesla about 350 volts possibly. What do you build your battery packs at?
So the nominal voltage is about 800 volts.
Wow.
Simply because, as I just said before, more voltage you have, less current you will generate. And the current is the source of heat, basically. So if you have a lot of current, you will have to have bigger copper, so more weight, more current, so everything will generate more temperature. So basically the system is a bit less efficient as a whole.
So they're always topping up the batteries, they get back into the pits, they're plugging in, so you don't really need to worry about a charge curve so much because it's always just topping up. But how low could a battery get? So say they've done a full race, they've used maximum power, they boost every lap as well. How low do they drain the batteries down to?
Oh, they can go down to 8%, 5%, and after a while, we just the system, so the brain in the battery, just will degrade a little bit the power to make sure that the car can come back and to don't damage the battery. But the race events and the course, it's designed to make sure that when they do the race, the 2 or 3 laps race, they come back and they'll have left 15–20% of SOC.
Perfect. Now I can see you are here with your team members as well. On a race weekend, what's the role of Williams Advanced Engineering and the support that you're giving the teams? Because I've seen you've been dashing about with laptops,
Yes.
and your colleagues here have been working with the teams as well. What are you doing with them?
So the routine job, I would call it, is to basically nurse the battery. So every time the battery comes after a run, after an outing, we call that, we go and we download the data. So inside the battery, we have a logger, like a computer with an hard disk, basically. So all the data are logged into this hard disk. We go with a laptop, we download this data, and every outing, we check every temperature, every voltage for every cell. So we have the whole history of what happened in the last 10, 15, 20 minutes during the race. So we collect this data, we compare that to the model we have some algorithm as well to check. And when everything is okay, we say, green light, you can go ahead. Otherwise, if we see something, maybe something that we don't like, or something which show a little bit of any kind of risk, let's say, if any risk, or after a crash or an accident, we're gonna take the battery away, give them another battery, because to change the battery is about 40 minutes, 45 minutes, so our spare battery are always charged and ready to go. And then with my technician, we're gonna open the battery, open the lid, check the internals, have some parts to be for maintenance, and we do some preventive maintenance is necessary, or we just check and put back the lid on and give it back to the team. So yeah. That's
wonderful. And even on a day like today when we can see outside, it's so muddy, it's a bog out there. It's endurance. They can cope with a huge amount.
Yeah, so I think the main target, the main requirement for this battery was robustness, was maintenance in the field, because this pack never come back home, and they have been loaded on the St. Helena at the beginning of the season, and we haven't seen him for a year. So that's a challenge as well, to make sure we can fulfill to provide the battery for the whole season without seeing them. So we see them only during the events, during the race events. So robustness, safety. Safety, I would say, is number one, because we knew the car will be used in extreme environments. And that means the accidents, but as well the temperature, the sound, the dust, the humidity, everything you can normally take a battery away from, we make a battery that can take it.
Amazing. Well, thank you so much for your time today. It's been awesome. Thank you.
All right, no problem.
Our final look behind the scenes, backstage access at Extreme E. Now, if you've watched this series already on TV, you'll recognise this area. This is the command centre. It's where the team managers and the drivers who aren't in the car, obviously, all get to talk to the engineers. They get to use these radio comms here to talk to the drivers in the car, to update them on the battles that are going on. They've got all their timing on screen as here. You can see the sector times on the screen. You can see where they are. You've got a visual layout of the course here, even the wind speed and how hot it is today. Air temperature 11 degrees. I can tell you what, it feels a lot colder than that today. This is an area that would be completely off limits normally, but of course we're here before racing starts, so we get an exclusive look behind the scenes for you and on the channel today. So what do you think about what you've seen today? Is it something that's got you hooked into electric racing? Are you now fully on board with EVs going racing, or are you yet to be convinced? Well, as we head back outside, as the light starts to go, all of the shakedown runs have been done, all the practice runs have been done, and now it's the job of the engineers in the crew areas that you've seen today on the show to get working, to make those final tweaks and checks before the race happens this weekend. Let us know what you thought about today's action online. You can leave us a comment below. If you're not yet subscribed, make sure you do so, and we'll see you on the next one.